Hi dear students, good morning to all. Myself Bhavsef Sononi, Assistant Professor, Department of Chemistry, Gokhale Education Society's Arts, Commerce and Science College, Java, District Palkar. Dear friends, in the previous part of the video lecture or the video online series based upon the surface chemistry, we had discussed or we had studied about the Langmuir adsorption isotherm. Dear friends, in the previous part, particularly we discussed about the various assumptions stated by means of Langmuir adsorption isotherm. At the same time, we have studied about the equation for Langmuir adsorption isotherm. Dear friends, in this part of the video, we are going to study about the validity of Langmuir adsorption isotherm. How we can study or how we can check whether the adsorption follows Langmuir adsorption isotherm or not, and that can be verified, that can be checked out with the validity of this Langmuir adsorption isotherm. Dear friends, based upon the previous equation that we derived in the last part of the video, we are going to discuss a validity of Langmuir adsorption isotherm. Before discussing the validity of Langmuir adsorption isotherm, I would like to clear one thing here based upon the previous part of the video. If you remember about the last part of the video, then we derived equation for Langmuir adsorption isotherm, and definitely one of the term in the derivation, it was a volume of the gas will be equal to maximum volume required for the formation of single layer on the surface of adsorbent into B into P divided by 1 plus Vp. After simplifying the equation, if you remember about the last part of the video, then we had derived the equation that P upon V is equal to simply 1 plus B into P divided by Vm into B plus 1 upon Vm into B. It was just the equation, that is P upon V is equal to 1 plus B into P divided by Vm plus 1 upon Vmp. Dear friends, the whatever equation that we had written in the previous part, definitely there is something changed in that equation, and you will come to that after simplification equation. Actually, this is the wrong equation. This is not the correct equation in the last part, and the actual correction is that after getting this term V is equal to Vm into P into P divided by 1 plus B into P, we can rearrange this equation into this, in which this P will be divided to this, and definitely we are getting this simple equation V upon P is equal to Vm into B into P divided by 1 plus B into P. After taking the reciprocal of this equation, we are getting this. It's very simple. P will be at the denominator, V will be at P will be at the numerator, V will be at the denominator, and simply we are getting the equation P upon V is equal to 1 plus B into P divided by Vm into B. And after simplification of this, so this will be simply like this, that P upon V will be equal to 1, this 1 divided by denominator Vm into B plus B, this B will get cancelled, and simply P upon Vm. And now I'm going to rearrange this equation. I'm going to write this term first and later this term, then I will get the equation P upon V is equal to P upon Vm plus 1 upon Vm into B. And this equation, this equation is called as the equation, or is known as the equation for Langmuir adsorption isotherm, and not this. Please try to correct it. Sorry for correction in the previous part of the last slide of the previous part. I hope you will make the correction in the last slide of the previous part, and you will go according to this equation for the validity of Langmuir adsorption isotherm. So it was the only correction. I hope you will follow the same. Based upon the same equation, dear friends, today we are going to study about how we can check the validity of Langmuir adsorption isotherm. So here, whenever we want to check the Langmuir validity of Langmuir adsorption isotherm, but before checking the validity of Langmuir adsorption isotherm, the water equation that we got for the Langmuir adsorption isotherm is that simply it was the equation that we got here for Langmuir adsorption isotherm is P upon V is equal to P upon Vm plus 1 upon Vm into B. And definitely if we have derived this equation from this, equation that V is equal to Vm into B into P divided by 1 plus B into P. It means that we can again write this equation in this form: V is equal to Vm into B into P divided by 1 plus B into P, and this equation is simply called as the equation for Langmuir adsorption isotherm. Here in this equation, suppose this is the equation of the interest. Suppose this is, I'm going to consider this is the equation A, and in this equation, suppose we will consider the different cases of the pressure at which the adsorption take place, and here I'm going to consider the first case at very low pressure. It means that the pressure is very small as compared to 1. It means that this B into P term is very small as compared to 1, and therefore this BP in this equation is going to be very small, is going to be very negligible, and hence 1 plus BP is nearly equal to 1. And if we'll put this 1 in the denominator, simply you will get the equation V is equal to Vm into B into P. Here Vm, this is the volume required for the formation of single layer on the surface of adsorption, so it has a constant value. This B is already constant. It means that V is directly proportional to this. V is directly proportional to what? V is directly proportional to the pressure, and from this case, first we can conclude that volume of gas adsorbed is directly proportional to the pressure of the gas. Here at low pressure, we got the relation volume of gas adsorbed is directly proportional to pressure of the gas. What will happen if we will change the temperature, if we will change the pressure, or we will increase the pressure? So what will happen? What will be the relation between volume of gas adsorbed and the pressure at very high pressure? So in the second case, suppose we will increase the pressure to the highest value. Again we have the same equation for the Langmuir adsorption isotherm, and this equation is known as equation for Langmuir adsorption isotherm. So here in the second case, suppose we will increase the pressure at higher value or at high pressure. What happens? This pressure is high. It means that this term is having considerable value. It is very greater than the 1, and therefore 1 plus BP in the denominator of this equation is going to be nearly equal to B into P. So definitely, so in the denominator there will be only B into P. So this B and this P and P will get cancelled, and simply we will get the equation V means the volume of the gas adsorbed will be equal to Vm. Vm means the volume of gas required for the formation of single layer. So at the highest pressure, what we are getting? V is equal to Vm means volume of gas adsorbed is equal to constant, means it is independent of pressure, and definitely it's going to be constant. So it's this is the relation between volume and the pressure at high pressure. So based upon the same equation, how we can check the validity of this Langmuir adsorption isotherm? Validity means whether the adsorption follows Langmuir adsorption isotherm or not. That can be studied with this Langmuir adsorption isotherm, and for that purpose definitely we has to consider the validity, and for that purpose again we will use the same equation, that equation derived by means of an Langmuir adsorption isotherm, or the equation for Langmuir adsorption, P upon V is equal to P upon Vm plus 1 upon Vm into B. Dear friends, if this is the our equation of interest into that and if this equation is considered with the equation of straight line, definitely you will be able to compare this equation with the equation of straight line. Then simply we are getting this equation is just equal to, or it is similar to the equation of straight line, y is equal to mx plus c. This is y is equal to mx plus c. So this is the y, this is m, and this is cy intercept. And whenever we will plot the graph of P upon V against pressure, then we will get the straight line with a slope 1 upon Vm and the y-intercept 1 upon Vm into B. Here you can see here, suppose here if we plot the graph of, that is P upon V versus P means the pressure, then we are getting such type of the straight line. We are getting such type of the straight line, and this straight line having y-intercept, and this y-intercept is equal to 1 upon Vm into B, and the slope of this line will be equal to 1 upon Vm, and this is the, it means that for any adsorption isotherm, if we will plot the graph of P upon V versus P, then we should get such a straight line having y-intercept and the positive slope, and that slope will be equal to 1 upon Vm. It's very simple. And if we are getting such type of the straight line having y-intercept and positive slope, then we can say that this adsorption follows Langmuir adsorption isotherm, otherwise it will not. So here we should get such type of the graph, we should get such type of the plot having y-intercept and the positive slope. Dear friends, after the study of Langmuir adsorption isotherm and its different cases as well as validity of the Langmuir adsorption isotherm, it is particularly applicable to monolayer adsorption. If you remember about the assumptions stated by means of Langmuir, then definitely this Langmuir adsorption isotherm particularly applicable to monolayer adsorption. But what happens actually if the adsorption is multilayer adsorption? Then what will happen? And this problem is solved by means of this equation or the adsorption isotherm called as Bate adsorption isotherm. Actually this word Bate come from the initials of the name of the scientist who has derived this equation of the adsorption isotherm. Here it is observed that Langmuir theory of unimolecular layer is valid only at low pressure, because we discussed about the cases, because at the high pressure this adsorption is independent of pressure and is going to be constant, and at low pressure definitely this adsorption or the volume is directly proportional to the pressure, and that's why the Langmuir theory of adsorption of unimolecular layer is only valid at the low pressure. It means that at high temperature, it means that it is not valid at high pressure and low temperature. It is also observed that with the increasing pressure or decreasing temperature, the initial monolayer means the first layer acts as the substrate for the formation of another layer or for the formation of multilayer adsorption. It means that there will be the deposition of one layer over the earlier layer. It means that the earlier layer acts as the substrate for the formation of another layer or the multilayer, and this concept of multilayer adsorption was extended by means of the scientists who is known as Stephen Brunner, Paul Emmett and Edward Taylor, and derived a particular equation, and that equation is called as the Bate equation. Actually this derivation of the Bate equation is depends upon the various assumptions which can be stated below as. The first assumption stated by Mr. Bate adsorption is that the adsorption of gas molecule on solid adsorbent is of multi-layer type rather than unilayer or unilayer or monolayer adsorption. It's very important that to study. So adsorption considered by means of an bit adsorption isotherm on the solid adsorbent is multilayer rather than unilayer or monolayer adsorption. Again, Langmuir's assumption, they have applied this Langmuir's assumption to each layer separately. It's very important because though the multilayer adsorption is considered by Bate equation, but they have applied this whatever assumptions stated by means of an Langmuir to each layer separately. And according to the Bate adsorption isotherm, there is always existence of dynamic equilibrium between the various layer or between the successive layer in the sense one after the other. So there will be a dynamic equilibrium between first and second and third and fourth layer, not first and third layer, successive layer. And at equilibrium it is also observed that the rate of desorption from first layer is equal to the rate of condensation of the preceding layer. Rate of desorption means the removal of adsorbed gas molecule, and condensation is the that is adsorption. So rate of desorption from the first layer is equal to the rate of simply adsorption of the preceding layer, and the heat of adsorption is applicable to only first layer. This heat of adsorption concept will be applicable to only the first layer, and after the first layer the heat of adsorption is equal to the latent heat of condensation of the vapors. And here the forces that produces condensation are responsible for the binding energy in a successive multilayer in successive multimolecular layers. So these forces are responsible for the binding energy in successive multimolecular layer. So with the help of these assumptions, statements of an Bate equation, Bate adsorption isotherm, the equation for Bate adsorption isotherm is given by means of these three scientists. According to them, they have modified the Langmuir adsorption isotherm as P upon V into P0 minus P divide is equal to 1 upon Vm into C plus C minus 1 divided by Vm into C into P upon P0. This Vm is the volume of gas required to cover unit mass of adsorbent with the single layer. It's very important for the formation of single layer of unit mass of the adsorbent. The whatever volume of gas is required, that volume will be called as or will be designated as the Vm. So it will have the constant value because it is per unit mass, and V, it is the equilibrium volume of the gas adsorbed per unit mass at pressure P and the temperature. So this is the volume of the gas adsorbed on unit mass of adsorbent at a particular pressure P and the temperature T, and P0 is the saturated pressure, vapor pressure at temperature, and C is a constant here. It will be equal to e raised to delta H1 minus delta H means the heat of adsorption divided by that is latent heat of adsorption minus heat of adsorption. It's divided by R into T. So dear friends, today in this part of the video we try to discuss about the correction in the Langmuir adsorption isotherm equation, and after that we also try to study about the different cases of the Langmuir adsorption isotherm. What will be the relationship between volume of gas adsorbed and the pressure at very low pressure and the high pressure. Definitely it follows only at the low pressure. And after that we studied about the validity, how can we check the validity of Langmuir adsorption isotherm equation. And after the same we studied about the Bate equation, which can be applicable to the multilayer adsorption with the help of Langmuir adsorption isotherm. Definitely there is some modification in the Langmuir adsorption isotherm done by this scientist, extended by this scientist, and they have applied these concept or the assumptions separately to each layer in the multilayer adsorption, and for that they considered the first layer acts as the substrate for the adsorption of the next layer, means for the multilayer adsorption. So today we try to discuss, we try to study all this concept, and in the next part of the video we will study about the validity of bait equation, just like the Langmuir equation, or validity of the bait adsorption isotherm equation, just like the equation for the Langmuir adsorption isotherm. So dear friends, we will again resume in the next part of the video to discuss about the validity of equation for bait adsorption isotherm. So thank you very much. Thank you.